How big is the proton? My research here at Stony Brook University is focused on answering this one question. And I can tell you right off the bat that we don't know. Although we don't know with an asterisk at the end. We know that it's probably very small, but we don't know exactly how small it is. You might wonder why we're interested in measuring the size of the proton. Why do we care? Well, if you remember back to your high school chemistry classes, hydrogen is the first element on the periodic table. And hydrogen is made of one proton and one electron in orbit. And the universal ingredient label for everything in the visible universe, you, me, my laptop, everything around us, is built out of hydrogen and time. So by studying the proton at the center of hydrogen, we're able to gain a deeper fundamental understanding of the world around us and the world in which we live. So how do we measure the size of the proton? Well, there are two methods for doing so. There's method one, which we call scattering. And the analogy for scattering is playing billiards or pool. You have your cue ball and you have an 8-ball, and you shoot the cue ball at the 8-ball. And if you're like me and bad at pool, you scratch and the cue ball goes off into a corner pocket. If you know how hard you hit the cue ball and what pocket it goes into, you can infer the size of the 8-ball. And that's exactly what we do in scattering. We shoot a beam of electrons at a proton. And by knowing how quickly we shoot the electrons and what angle they bounce off the proton, you can infer the size of the proton. And I have a little video here showing just that, an electron coming in and bouncing off the proton at some angle. The second method is called spectroscopy. And in this method, you take a hydrogen atom, a proton with an electron in orbit, and you shoot a laser at it. This laser interacts with the electron and jostles it back and forth just a little bit. And by measuring how much the electron is jostled, you can infer the size of the proton. So these two methods have been performed, and I have the results right here. From method one and method two, scattering and spectroscopy, we can see that the size of the proton is 0.875 femtometers. That's 10 to the minus 15 meters. This is almost inconceivably small. The sense of scale here is comparing a proton to your billiard ball. It's like comparing a grain of sand to the size of the Earth. But even that is off by a factor of 10,000. It's more accurate to compare a grain of sand to the size of the Earth's orbit around the sun. As I said, it's incomprehensibly small, but the takeaway message is that we can measure how big the proton is, and we can see that it's not zero. And on this figure I have here, we have uncertainty on our data points. We have these error bars. And these error bars give us an estimate for how precise or how accurate our measurement is. So you might look at this and say, wait a minute, it looks like within the uncertainty of this measurement, you know how big the proton is. What gives? Well, in the past 10 years, there were two new methods developed for measuring the size of the proton, method 1A and 2A. And these are directly analogous to method 1 and 2 that I already told you about. The only difference is you replace the electron with a muon. So you do muon scattering or muon spectroscopy. And a muon is identical to an electron in every way, except it's much heavier. So 6 years ago, method 2A, muon spectroscopy, was performed. And the result is shown here, that red point on the bottom left, 0.84 femtometers. And you might think, wait a minute, where's the precision on this measurement? Well, it turns out this new method was so precise that the uncertainty on the measurement is so small, you can't see it on the scale of this figure. So when I say we don't know how big the proton is, this is what I'm referring to. We have three different methods that have been accomplished for measuring the size of the proton and two competing results. When you measure something with a ruler and with a meter stick, once you convert between feet and meters, you should get the same size, but that's fundamentally not what we're seeing here. My work is on method 1A, muon scattering, and we're currently in the middle of our data taking and analysis for the experiment. But we hope that once we have all of our data taken and analysis finalized, we'll be able to conclusively determine whether the proton is on the 0.84 femtometer side or the 0.875 femtometer side. So we can finally answer the question, the proton is small, but how small is it really? Thank you.